Let's suppose you got your first job. You make $8 per hour. We're going to create a table that shows the amount of pay that we'll make based on the number of hours that we work. If we work 0 hours, we don't get any money at all. If we work 1 hour, we get $8. 2 hours, $16. 3 hours, $24. 4 hours, $32. 5 hours, $40. And each hour we work, we get $8 more. Now, let's take these points and plot them on a graph. Here we have a scatter plot, and notice that the points are very much in a line. If I connect those points with a single line just like this, we see that there's really a linear relationship. And when we say a linear relationship, we mean that the points lie in a straight line. Today we're going to talk about direct variation, and direct variation is really just looking at things that have linear relationships. When we have a linear relationship with direct variation, the graph has to pass through the origin, or through the point 0, 0. It cannot pass through any other point at the y-axis. It has to pass through the origin. Some important points to note. First of all, it does have to pass through the origin, and it does have to be a straight line. We say that there's direct variation between x and y, or we say that y varies directly as x. When we see that something varies directly, we know that it forms a straight line. In our example, notice that the slope of that line is 8. That means that every time x increases by 1, y increases by 8. In other words, every 1 hour you work, your pay goes up by $8 more. When we're talking about variation, the slope is called the constant of variation. It's the amount that it goes up by each unit increase in our x value. So x goes up by 1, y goes up by 8. The slope, the constant of variation, is 8. In our first example, we have two variables, x and y, and it says that they vary directly. They say when x equals 5, y equals 20. First thing they want us to do is find the constant of variation. Well, it's useful to know that when it says they vary directly, it means we have a line. The constant of variation is really just the slope of the line. And remember, slope is y over x. Because they told me it's a line, and they gave me a y and an x, I can plug those numbers in. Y over x is 20 over 5, or 4 over 1. So the slope of the line is 4 over 1, which is also the constant of variation. When we're talking about direct variation, we're really dealing with proportions. They say x equals 5 and y equals 20. Then they say, what is y if x equals 10? Well, really, we're just setting up a proportion. Y over x equals y over x. 20 over 5, which is what they gave us at the top, equals y over 10. The y is what they want us to find. And we cross multiply and solve the proportion, we find out that y is 40. So when x is 10, y is 40. So really, the idea of direct variation really just takes everything we've already done and brings it together. In the second example, they tell us that the variables x and y vary directly. That means it forms a straight line. They say x is 12.8 and y is 3.2. They want you to find the constant of variation. The constant of variation is the slope of the line y over x. That's 3.2 over 12.8. That equals 0.25, or 1 over 4. To find the value of y when x equals 5, we can use a proportion. So y over x equals y over x. And then I can plug my numbers in, cross multiply, and solve the equation. When x is 5, y is 1.25. The next example is for you to try. They tell us that x varies directly as y, which means we have a direct variation. X is 2.4 and Y is 804. The first thing they want you to do is find the constant of variation K, or the slope of the line. Then they'd like you to find the value of X when Y equals 336,675. Please pause the video here and try this example. In this case, we want to find the constant of variation, or the slope. Y over X, 804 divided by 2.4, that's 335. So the slope is 335 over 1, which is also called the constant of variation. To find the value of X in part B, we're simply setting up a proportion. We have the first one, 804 over 2.4, equals 336,675 over X, cross multiply, and solve for X. In this case, we see that X equals 1,005. The next example is also for you to try. Please pause the video here, and then come on back, we'll see how you did. In this example, they wanted us to find the constant of variation. Because it varies directly, we knew it was a line, and so we know that the constant of variation is really the slope, Y over X. I plug the numbers in, and I see that the constant of variation is 4 over 5. Now I want to find the value of X if Y equals 12. Because it's a linear relationship, direct variation, we know that we can set up a proportion. Then we can solve the equation. We find that X equals 15. There's also some great applications of direct variation, and really, it's nothing more than proportions. So really, you've already done this. You're just putting a different name on it. In this example, it says there are 90 calories in 20 grams of cheese. Reggie ate 70 grams of cheese. How many calories were in the cheese that she ate if the number of calories varies directly as the weight of the cheese? Varies directly means I have a proportional relationship. And so I'll set up a proportion, calories in grams. That gives me 90 calories in 20 grams, Y calories in 70 grams. And now I cross multiply and I solve the resulting equation. It turns out that in the cheese, the 70 grams, there were 315 calories. The next example is for you to try. We have medication that's prescribed for a person, and it says it's directly related to the person's weight. If you weigh 50 kilograms, you get 2 milliliters of this medication. If you weigh 75 kilograms, they want to know how much medication you would give. Because it says it's directly related or directly proportional, you can set up proportions in order to solve this problem. Please pause the video here, then come on back, we'll see how you did. In this example, we're comparing the weight with the amount of medication. Directly related means directly proportional. We can solve using a proportion. 50 over 2 equals 75 over X. Now we cross multiply, solve the equation, and we find that X equals 3. So a 75 kilogram person would take 3 milliliters of medication. In our final example, we're talking about the distance a body falls from rest, and it varies directly as the square of the time of the fall. An object falls 64 feet in 2 seconds. How far will it fall in 5 seconds? Really, all you need to know when you look at this is varies directly means varies proportionally. It's a proportion. And so we're setting up a proportion carrying the distance it falls and the amount of time. Please set up the proportion and then solve to find out how far the object will fall in 5 seconds. Please pause the video here. In this example, we're comparing height and time. 64 over 2 equals Y over 5. Cross multiply and solve the equation, we get that Y is 160. So in 5 seconds, the object will fall 160 feet. So really, when we're talking about direct variation, we're talking about a line. When we're talking about the constant of variation, we're trying to find out what the slope of the line is. When we solve these problems, really, we're just dealing with proportions. And so it's really nothing new, just a little bit more vocabulary makes it sound a little bit different. Remember, the graph has to pass through the origin, and it has to be a straight line. And this is everything you need to know to get started working with direct variation.